All right, guys, welcome to this page of the notes. So what I want to do here is now talk about that second objective or learning target, which had to do with extrema, the relative maximums and relative minimums. Now, it's really actually a pretty simple idea. We've actually talked about it a little bit already. This idea of turning points, you know that the polynomial is going to change directions probably several times. The way that we do that, right, is remember you find the degree of the polynomial, which we call n, then the number of turning points, the number of times the polynomial is going to change directions is n minus 1. It's always one less than the degree of the polynomial. So let me highlight that for you because that actually is really, really important. It's the second time we've seen it, and if it bears repeating, that means it must be important. Anytime you change direction, those turning points, they're going to be known as extrema because they're going to represent a maximum or a minimum. And I've got an example of a polynomial drawn right here. Please notice that looking at it, you see the polynomial changes direction twice. I'm headed down and then I change direction to up. So that's one change in direction. I'm headed up and then I change direction and I head back down. So I've got two turning points, right? I have two turning points, and both of those turning points represent either a maximum or a minimum, right? Obviously, the one that you're headed down and then shift up is going to be a minimum. When you're headed up and then shifted down, you're going to be a maximum. I know you guys know what maximums and minimums are, so that's what we're going to be looking for in our graphs of polynomials, these maximums and minimums. So extrema, the turning points of a function will generally be relative maximums or minimums. And these are points on the function. These points on the function are called extrema. Again, it's either going to be a relative max or a relative min. So what you guys are going to do, again, this one's already been worked out for you, so we'll do one together here in a second. You're going to set up your table. Right? You're going to go through, you're going to find your consecutive integers if you have any. We're looking for zeros or consecutive integers. And then once you've got your graph, we're going to go ahead and find those relative extrema as well, those relative max or relative mins, which again, all of that will come right from your table. Again, this is, once you've set up your table, you have done all the hard work. Everything you need will then come from the table. So let's go ahead and do an example problem, which I have for you right here on this page of the notes. All right, here we go. Set up my XY table. Again, I'm going to start at 0, 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Guys, it is a whole bunch of plugging and chugging just like before in your calculator. Don't fat finger something, and here's what you should wind up with. When you plug in a 0, you should get a negative 2. Positive 1 is going to be a negative 3. 2 is going to be at 10, 3 is going to be at 49, 4 is going to be at 126. Guys, that's not coming back. That's headed to positive infinity. Go the other way. Negative 1 is going to be at a positive 1. Negative 2 is going to be at a negative 6. Negative 3 is going to be at a negative 35. Negative 4 is going to be at a negative 48. Look at that. That is headed to negative infinity, right? Those numbers are just going to keep getting smaller and smaller and smaller. Now let's check to make sure that that makes sense. My polynomial, 3, 2, 1, 0. It's already in standard form. That means the degree of the polynomial is a 3. That is an odd number, and I know that my ends have to go in opposite directions, which is exactly what I see here. This end, that will be the right-hand side, is headed to positive infinity. The left-hand side, as I come this way, is headed to negative infinity. Those are opposite directions, which is exactly what it should be. It's an odd degree polynomial. The leading coefficient is a 2. That's a positive number. Well, remember the way it worked. If you're odd with a positive leading coefficient, the right-hand side will go to positive infinity, which is exactly what my table is telling me. So I feel pretty confident here that I've got this set up right. Let's go ahead and plot these points and see what this sucker looks like. Let's see, 1, negative 3, 2, 10, and then they just get bigger from there. Negative 1, 1, negative 2, negative 6. And then they just go down from there. So it looks like what I've got is something that looks like this. And just to give you guys a little bit of confidence, hopefully I didn't shatter your confidence with the last problem. Remember, the last problem we graphed it, and I said that if you were to graph it on a graphing calculator, it wouldn't look exactly like what we got. Turns out this one is this is exactly what a graphing calculator is going to show you. Please don't lose confidence. Not all of them work out perfectly, but a lot of them will. This one, if you were to graph this on a graphing calculator, you would get a picture that looks exactly like that. So please don't lose confidence in this method of graphing. It does work. It doesn't work all the time, but it's good enough. It's good enough for now. That's why we're starting with it. It's not the perfect way to do it, but it works. It's good enough. It's a great way to get started. Let's go ahead and find our consecutive integers, and I ask you, right, check this out. I want you to find the relative maximum or minimum. So here we go. I'm looking for sign changes, and it looks like I've actually got a couple of them. I changed sign here, here, and here. Now that makes a whole lot of sense, right? It is a third degree polynomial, which means I should have 3 zeros. 1, 2, 3. I do have 3 zeros. So let's go ahead and write my consecutive integers. I'm going to have a 0 between negative 2 and negative 1. I'm going to have a 0 between negative 1 and 0. And I'm going to have a 0 between 1 and 2. So these are my consecutive integers. Awesome, no problem. Now what I'd like you to do is find those maximums or minimums, which means you're looking for turning points. Well, I got a turning point right there, which is representative of a maximum. And I got a turning point right there, which represents a minimum. Now, what I'm not saying, actually, this is really important. I said maximum and minimum. I should have used the full name, a relative maximum and a relative minimum. What that means is this is not the maximum point, right? Please notice that all of these values over here are way bigger than this value, right? These are all much higher numbers, which means if I'm looking for an absolute maximum, I'm going to be somewhere way over here, right? Because these numbers are going to infinity, and those are going to be my maximums. This is not the biggest, or this is, sorry, the biggest, smallest number. That makes no sense. This is not the smallest number. These numbers over here are way smaller. Way, way smaller. So that's the reason we call it a relative maximum and a relative minimum. Relative to the points around it, that is the highest point. And relative to the points around it, that is the lowest point. So a relative max and a relative min, meaning relative to just the other points around it, it's the highest or the lowest, all right? Absolute maximum or absolute minimum would be the absolute highest or lowest value, not what we're looking for here. So my maximum, well, where does it occur? It looks like that relative maximum occurs at this negative 1, 1. This guy right here is my maximum, which happens at x equals 1, y equals, x equals negative 1, y equals 1, which is the point negative 1, 1, if you wanted to write it as a point. And my minimum, it appears, would occur right here at 1, negative 3. When the x value is a positive 1, the y value is a minus 3, which is an ordered pair would be 1, minus 3. So there we go. I've got my consecutive integers. I've got my relative maximum, my relative minimum. I've given you both the ordered pair for that relative max and relative min. I've given you each of the individual coordinates, the x coordinate, the y coordinate for both the max and the minimum. And guys, that takes care of everything that you would need to know when it comes to graphing polynomials using the table method and the kind of stuff I'm going to ask you for. Thanks so much for joining me for this set of videos. I'll see you guys next time.